I'm Jeremy Regnerus, and today we're going to be taking a look inside of here. We're going to be taking a look at creating gears. It's a commonly asked question we get a lot on the SOLIDWORKS forums. You see questions on YouTube. There's various resources how to do this, and I thought it'd be pretty fun today to take a look at how do we design a gear, but how do we leverage some of the intelligence that we have inside of SOLIDWORKS to do this? So some of the things we're going to look at have actually been highlighted in a previous live design. Last week, Jordan Tadich talked about designing stairs to fit any application, where he gave kind of an overview of equations. We're going to go really deep with equations today. If you're new to live design, I encourage you, check out the playlist that we have on YouTube. You can go back and see Michael Steves designing and making a growth chart. The famous Mark Schneider showing how to master model mania. We had Mike Sandy designing a new desk using some cool weldment tools in SOLIDWORKS. So he was actually showing how to do wood designs with weldment tools. It's one of the interesting things about SOLIDWORKS. Though tools may say weldments or sheet metal, they can definitely be used for different things. So that's a really good one to go check out. Mike Sabocek did a really cool design of a pinion shaft support for his own custom hot rod that he did. And then early on, we had Andy Barnes designed a snowboard wax iron. Cool surfacing tips and tricks in there. If you are interested in surfacing, go back, watch that video. Early on, Brian Zayas did a flexible monitor mount where he both looked at part design and some sheet metal design, which was really cool. And then when we kicked this whole thing off almost a month ago, Toby Schnars started us off with a coffee mug design while drinking coffee. Again, showing some really cool modeling tips and tricks, how to master filleting and other things like that. And we're not done. We've got a lot more episodes coming up. Next week, we have Juan Chapa is going to be designing a pergola using weldments. And then the 15th, what's really cool is we have live design and we also have SOLIDWORKS live. We're going to have a really cool opportunity to meet with a customer at Square Robotics, kind of talk about what they're doing with SOLIDWORKS and the 3D Experience platform. So if you're interested in that, that's a different format. It's not really this pick and click. It's more of we're going to have a conversation with a really cool customer. So definitely tune into those. And we're going to be doing live design for the foreseeable future. So if you haven't, make sure you go down there and click that subscribe button. Hit the bell icon as well to make sure you get notified when we go live. As we're going through this demonstration today or designing this gear, make sure you post in the comments over here on the side. We're going to be answering those comments. We have some folks from our team who are going to be joining in, answering some of the questions. I'll be taking a look at it over to my side over here. And then one of the things we got to ask is, what do you all want to see? So when this video is done, it'll be recorded. So you can always go back and watch it later. Make sure in the comments down below, when the video is finished, give us some ideas of some of the things you're interested in seeing. Do you want to see more weldments? Do you want to see more sheet metal, surfacing, assemblies, drawings? Make sure you let us know. You can put them in the comments and somebody will take note of that, or in the live comments. But if you put them in the comments when the video is done, they'll be easier for us to go ahead and grab those. So I'm going to dive in. Enough talking. I think it's time we start looking at designing this gear. So I'm going to go ahead and switch over here. And we are going to take a look at this original design. I've had a lot of people really like this. There's a lot of gears, a lot of motion happening inside of this design. What we're going to do is we're going to focus on creating one of these gears first. And then we will come back and for bonus time, we'll get an opportunity to look at some of the assemblies, mates that we can add to bring all of this motion to life. So let's go ahead. Let's start by creating a brand new part. I'm going to be working in the metric system. I live in the United States. Oh, I should have started by saying good morning, good afternoon, and good evening wherever you're joining us from. Make sure you let us know where you're joining us from over in the comments on the side as well. But back to the model. I'm going to be working in metric units. I prefer them. They're easier to use. and especially when it comes to gear design. So when it comes to gear design, you actually have a lot of ways you can approach tackling designing a gear. You can deal with the pitch diameter, the number of teeth, the module system, which we're going to be using in the metric system, which is a really easy way to design a gear. Basically, when you design a gear, you usually need to know two numbers: the center to center distance, the gear ratio you're after, any variety of these numbers. We're going to create a blank gear, and we're going to do it using the module system as we go through this, in the number of teeth. Before I get started actually modeling this part, I should point out a couple other things. If you just need a gear, it's actually probably in your best interest to go right to the manufacturer. They probably have SOLIDWORKS models for you. And in fact, you can also go to Parts Supply at 3ds.com and you can find gears here as well. So if you don't want to go through this whole process and you just want to download a file, you can go on here, you can search for it, you can find a variety of gears, you can configure them any way you want. So Parts Supply is an awesome resource to just go get a gear and put it into your design. However, I understand that some people want to create them because they want to make custom modifications to them. So let's go ahead and get started. So I'm going to start this gear on my front plane. I'm just going to start a sketch. And one of the first things you have to think about is, what are the most important things I need to capture in my design? Well, the first thing that we're going to look at is, I talked about the number of teeth in the module system. I think it would make sense to capture those numbers right away. A good way to do this is, in our equation system, we have something called global variables that you can set. And you do this in the equations folder. But when I go over to my tree, the equations folder isn't there yet. Well, all of these items that are in your folder that seem to magically appear and magically disappear on you, they're always available to you by right-clicking and going to the hidden tree items. You'll notice things like my solid bodies and surface bodies folders that appear and disappear kind of as you're modeling. They're actually here, and you can control those and you can access them at any time. So you'll see I can actually go right into Manage Equations even though that equations folder isn't there yet. And what we're going to do is we're going to capture those two values. The module system that we're working with, so let's use a value called module in this case. Let's spell it right, actually. You'll notice that the letters are in red. That's because global variables need to be encapsulated in quotation marks. But what's really cool is if I just click the tab key, you'll see SOLIDWORKS enters that for me. So then we're going to enter our value that we're looking for here. And we're going to create a 2 millimeter module gear inside of SOLIDWORKS. So I'm going to type 2. And I'm going to, for the sake of it, I'm going to type mm after this. And the reason I'm doing that is you may come into a situation where you want to change the units of this model to be inches, for example. By setting this to mm, I'm always telling SOLIDWORKS, use this as a metric value. The other thing we wanted was the number of teeth. And you don't have to put long names in here, but I like to make them descriptive. And this is going to just simply be an integer value of 25. So we're going to create a 2 millimeter module gear with 25 teeth on it. So we have those values. You'll notice as soon as I add them, they now appear in the equations folder over on the left-hand side of the feature manager tree. And now I'm going to start sketching. And I'm going to sketch the most important thing, probably the only thing you actually need to design a gear. Anybody take a guess? I'll give you a second. Put it in the comments. What's the most important value on any gear that you need over here? Give it like 5 seconds. Pitch diameter, right? So that's the number one thing that we want to be working on. The number one value we need to capture is the pitch diameter. So I'm going to go in here and I'm going to go reach for my machinist handbook, and I'm not going to do that. I'm going to let SOLIDWORKS do all the hard work for me. The equation to calculate the pitch diameter for metric module design gear is actually really simple. It is the module value times the number of teeth. So how do I capture that? Do I type 2 times 25 and remember those? No, we're actually going to let SOLIDWORKS do a lot of this work for us. If you press the enter key whenever you're entering a dimension, anywhere in the software, it'll start generating an equation to do this. And we have different things we can access, from the file properties, some functions we can perform, and those global variables we just accessed. So I want the module value, and we're going to simply multiply this by our number of teeth. When I hit this little green checkbox, it'll immediately evaluate the number, and it'll give me this equation symbol here to always let me know that that value is driven by an equation. And when I press OK, you'll also see that it has this equation symbol next to this dimension. It lets me know that that dimension is being driven by that equation value. So this is probably the key thing. We're good, right? No, we'll keep going here. Let's get the outside diameter of our gear next. So I'm going to press my S key to bring up my shortcut menu. Lots of people have talked about customizing the shortcut menu already. Go back, watch those live designs, and learn how to do that. We're going to draw another circle here. Now, the outside diameter of a gear can be calculated numerous ways. In fact, you can use a lot of different calculations than what I'm doing here. I'm highlighting some that show off some capabilities of equations. The reality is the easiest way would be to set the addendum value on this gear, which would be equal to, and notice this, when I start typing, it gives me a list of values. It would be equal to the module value. That's like the easiest way to do it. I want to show how to make a slightly more complex equation here, though. We're going to do this by doing some longer math in this case. What we want to do is the outside diameter can also be calculated by a formula of the number of teeth plus 2 times the module. Now that starts to get into some of this order of operations stuff. If I just wrote number of teeth plus 2 times module, that would give me 4 plus 25, and that's not the value that I want. We need to encapsulate part of our equation in parentheses, which we can do. I'm going to press the equals key. I'm going to start a parenthesis. And what we want is the number of teeth. So I'm just going to start typing that value, and it makes it really easy for me to find this. We're going to add a value of 2 to it and encapsulate that in the parentheses. We're then going to multiply that by our module value. And press OK. And you can see that this is also driven by an equation. Now, to verify our work, we could go in here and add another dimension. Look at that. It's the number 2. It's the same as our module value. In fact, I'm going to place this because I want to show something that some people get confused. This dialog box. What does this mean? Dimensions in SOLIDWORKS can be used to control the geometry or simply reference the geometry. And in this case, that value is important to me, and I may need it on a drawing later on. So I'm going to go ahead and press OK, and you'll notice it's in gray, which means that it is going to be a reference value. I can import that into a drawing, and I can always kind of look back on it. So I'm going to take a look at the questions over here. I see my question I asked earlier, the pitch diameter. Everybody really got that. Lots of people giving us good suggestions for things we want to do later on. All right, so let's keep moving on here. So we've got this done. I'm going to close this sketch. I'm going to be dropping in tips and tricks as I go through here. So this might not be the way you think you need to work, but I'm trying to show a few things here as well. I'm going to go to an isometric view. You've seen this a lot if you've tuned into live design. I use mouse gestures all the time, but I predominantly use them for visual purposes. My standard views, my left, front, top, right, isometric. I'm going to go to an isometric view, and you'll notice I have this option called Instant 3D Enabled. What it allows me to do is simply select a sketch and start dragging it out. And you'll notice here, it immediately starts turning this into a 3-dimensional model. If I press and hold the M key, it'll actually start extruding that about the midplane. Now, when I release this, something happened. This doesn't look like a gear that I want to work with right here. Well, what it did is it created an extrusion between the outer diameter and the pitch diameter. So how could we solve this? Well, there's a couple ways you could do this. You could go in here and you could turn this into a piece of construction geometry, and it would update the way you would expect right here. Sounds like my volume needs to be increased. Let's see if we can't increase that volume a little bit there. Apologize for that. All right, so the next thing we want to go ahead and take a look at, we were looking at what was another way we could have done that. I am going to go in here and change this back to not being a piece of construction geometry. What is another way I could handle this? I think it's been highlighted before, but SOLIDWORKS has this concept of selected contours in any feature that you're creating. It gives you a lot of flexibility to put a lot of geometry inside of a sketch and pick and choose what you want to create a feature from. So for example, I could actually use this internal circle. I could capture that geometry we were creating, or I can pick whole shapes. For example, the outside diameter circle right here. So I'm going to go ahead, I'm going to grab that outside diameter circle, and there we go. We've got our initial shape. Let's go ahead and set some material to this so that it looks good as well. All right, so I'm being asked, I saw something about equations in here. How sketch equations are processed separately from model equations. So yes, we're going to be looking at equations and features. We'll even look at equations and mates as we kind of go through there in the different places you can use those. So we've got this done. The next thing we need to do is we need to start creating the tooth for our gear right here. So you'll notice that when I extruded this, I did it about the midplane, and that wasn't done on accident. Everybody in live design has taken time to talk about design intent and capturing that. And I, like everybody else, can't emphasize how important design intent is. By creating a midplane extrusion, I have set myself up for success by setting my front plane down the center line of my part. So now I have that in the center of my part. My origin is in the dead center of my part. Well, that's a really important area, or an important piece of geometry that I'm going to be referencing as we go on throughout here. So keep that in mind. I didn't create a midplane extrusion on accident. That was important. We're going to start creating not the tooth itself, but the cutout between the teeth. So, a couple things we want to do here. I want to start by creating a construction line because this is a symmetric piece of geometry. There's a couple other values here that I want to start thinking about now, and that's actually the distance between two teeth, or the distance between two cutouts, and then in between the two cutouts is an actual tooth itself. So we're going to drop 3 construction lines on here. Let's start by talking about an equation. We're going to add a dimension between the 2 cutouts of the teeth, where the cutouts of the teeth will be right here. And again, I'm not going to do 360 degrees divided by 25 in my head. I am going to press the equals key, and I will type 360 degrees divided by, and I'm going to go into my global variables and grab my number of teeth. And that angle is the angle between each tooth on my design. The angle here would be the distance between the center of them. So again, these will be the cutouts, this will be the tooth. I'm going to show you a couple cool tricks here. I could add another equation in here. I could come in here and make this angle be 180 degrees divided by our number of teeth, and that would give me exactly what we're looking for. Another thing I could do is a lot of people like to use the mirror tool to take a piece of geometry and copy it about a center line to the other side. One of the things you can actually do is you can define the center line itself. So take a look. As I grab the center line, I can grab these 2 endpoints and establish a symmetric relationship, and it will put the center line in the center of those 2 points. So symmetry isn't just for, I want to mirror geometry from one side to the other. It's a great way to capture construction geometry like this. So we've got those two numbers. That's a value I'm going to have to be working with here. There's two other values I need to work with here. There's going to be two circles. So we have what is our dedendum, or the working depth of our gear, and then we have the hole depth, which also includes clearance in there. So let's start with our working depth right here. This is a really simple equation. We're going to dimension from the outside of this arc to the depth of this. This is really simple. This is our module value times 2. So we're going to simply press OK there. So that gives us our working depth of our gear. The next thing we need is the hole depth, which includes clearance at the bottom of this. So let's go ahead. And now we're going to get into a really crazy equation right here. So the clearance at the bottom of a gear changes based on how fine or coarse the gear is. In the case of the metric module system, the values that I've seen say that if the module value is coarser or greater, equal to or greater than 1 1/4, the clearance on the bottom should be 0.25% of the module, otherwise 0.24%. Notice the value that I'm doing here, though. I'm doing the hole depth, not just the clearance at the bottom. So I'm going to go ahead here and we're going to create this. So what we're going to do is we're going to create an equation that, we got to press the equal sign. And we're going to come in here and we're going to grab the module value and we're going to multiply this by a variable. Now this variable changes, as I mentioned, based on the module value itself. We're going to do this using one of the functions in here. I want to create an if statement. I basically want to say if that value of module is equal to or greater than 1.25, we put a comma in. And here's what we do. We type in the value that we want it to be if the previous equation solved for true. So if module is equal to or greater than 1.25, multiply module by 2.25. Otherwise, meaning if it were finer, we would multiply it by 2.4. Keep in mind the parentheses there. I'm going to press OK. And you'll see here that it gives us our value. Now that value should equate to, if I look at that 0.25, I believe it should be 0.5 millimeter. And look at that. When I go and put that dimension in there, 0.5 millimeter is what I get. So you could have done this equation here. You could have just said, if it could have been module times, and then it could have, instead of multiplying it by 2.25 or 2.4, it could have been by 0.25 and 0.4, if that makes sense. So we're just capturing it as this hole depth right here. So we've got this. One other thing I want, and I'll discuss this later on, I'm going to create a slight offset here. I'm actually going to cause the cut to go outside of the gear slug here. We're now going to start drawing the tooth profile. And this is where I'm going to generate all sorts of controversy with the audience at home. I'm going to do this with an arc. I'm not going to do this with an involute spline. That would get into a whole new level of complication. And if you really need to draw and create an involute spline, you're probably the person creating the gear. And this probably isn't new to you. This is really for, I need a gear model in my design that I customize, and I'm going to send the specs for that gear to somebody. So keep that in mind. I am creating this with an arc, not an involute spline. I just want to get that out of the way right away. So let's go ahead. We're going to do this with a 3-point arc, and this arc is going to come from here, and we're going to go all the way to this offset value that I created, and we're going to create an arc here. I should probably take a quick look at the questions right here. I see something about the equation equation manager. So where are all these equations going? That is a great question. Whenever you add an equation, notice all these equations I've started creating show up here in the equation manager. You can go in, modify these, change these, see how they've been evaluated as you go through here. And we're going to take a look at this again in a little bit. So I've created the first half of my cutout. I want to mirror that over to the other side. So I'm going to use the mirror entities command, and here I'm going to use it just like normal. I clicked the center line. You'll notice I right clicked. That automatically advanced me to what you want to mirror about. So I selected the wrong thing here. Let's grab the entities to mirror. Right click, and now we've mirrored it over to the other side. So I need to control these a little bit better. The tangency of this arc needs to intersect at the center of this gear. So here, I'm going to use another construction line. We're going to just draw that from the endpoint there. And we want these 2 points, this point and this line, to be tangent to one another. So what I'm going to do is I'm going to select this center line and this arc, and I'm going to ensure that they're always tangent. That ensures that arc kind of points straight down to the center of my gear right there. The next thing I need to look at, we have 2 more values we need to get to before we can actually create this tooth. I need my cordial width, and I need my pressure angle. So you could do these in a variety of ways if you wanted to. I'm going to start with the cordial width because the pressure angle is probably one of the more complicated pieces here. So the cordial width is a point where that tooth engages with that pitch circle that we created in our very first sketch. I mentioned that circle, that diameter is going to be really important. We're going to go back and access that sketch geometry by simply going into the feature manager tree, and you can see here I can expand this extrude and I can show that. This is geometry that I can use whenever I want, and I'm going to reference it here. We're going to create a horizontal construction line, and I'll talk about why we're using a horizontal construction line as opposed to the cordial arc length in just a second. We're going to create a horizontal line at the intersection of those 2 points. Notice when I hover over this line next to my cursor, I get a little yellow icon. I think everybody knows that means it's going to add a coincident relationship. If I also touch this line first, which is on the other sketch, I get that same line. If I touch the underlying sketch first and then this line, I'll actually get I'll get 2 sketch relationships added to that at once. One to the underlying sketch and one to the entity in the current sketch. Now that takes a little bit of finesse. What if I just want to ensure that this point is always at the intersection of 2 lines? There's a lot of sketch relationships that I think people don't find because they don't realize you can hold the control key and select a whole bunch of stuff. And this list continually filters down to an intelligent list based on the entities you've selected. In this case, I've chosen a point in 2 arcs or lines, and I can create what's called an intersection relationship. That point will always fall at the intersection of those 2. So this is going to give us our basically our cutout width here. Now, if I were to go in and I were to look at this equation minus clearance, we're just going to create this line to line. Like I said, this is somewhat of a reference geometry. This width should be the same width as the tooth next to it. Okay, so I could come in here, I could create an equation. I think it's like the pitch circle divided by pi. I forget. I don't even want to get into that complicated of an equation. I'm going to show you a really simple way to use sketch geometry to solve a lot of this for you. On the tooth next to it, we're going to create another center line. And I'm going to just draw this out and make sure it touches this pitch circle. I know that the width of the cutout needs to be the same as the width of the tooth on that pitch circle. So I'm going to go ahead and say those are equal. Now, that's still not giving me a lot of definition right there. The thing you'll notice is this line is perpendicular to this line. Well, guess what? This line and this line also need to be perpendicular. And when I do that, that defines that width for me right here. This is now a known value that we can always come back and reference, or that we don't have to use a pi-driven equation. I will point out, if you want to add the value pi to any of your equations, you just type pi, and SOLIDWORKS will do the calculation for you. And it'll put the numerical value in there, I think out to 8 decimal places for you. So that is available in the equations as well. I'm doing these with relatively simple equations and letting sketch geometry control the rest of it for me. So, all right. There is a question about, is there a learning video for using an involute? Creating an involute spline would basically require me doing this same process around the arc of this circle, creating several arcs that kind of came in their tangency at that point. And that's why that would just take a long time to create that geometry. So you may be able to find something online for that. So I want to create a 20-degree pressure angle on this. And if you look at a lot of the charts online, this looks like it's a lot more complicated than it really is. Again, this comes down to geometry. Basically, it's going to be an angle of attack that this gear is going to meet the opposing gear on the other gear. We're just going to draw a line out here to capture this for reference, and I'm going to show you how we're going to simplify this process, because this is how you see it a lot in diagrams online. I needed to add a 20-degree value to that. Now, I'm going to show you a couple cool tricks here, so pay attention to these. A lot of people will look for a piece of sketch geometry to dimension an angle to. So for example, this construction line and this construction line, I could go in there and I could set my 20-degree attack angle basically right there. But that requires me selecting that geometry. Here's another cool trick. You can always dimension to geometry even if it's hidden, if it's selectable. So for example, because I'm looking normal to my gear, I can dimension to this top plane. Well, from a top plane view, that is a line. And then I can dimension that to that sketch and get my 20 degrees right there. So that's pretty cool. So say I didn't have a horizontal construction line. Say you don't even want to do that. Let's take a look at it. Something really cool. I'll point out I'm doing this in SOLIDWORKS 2020. I think what I'm about to show came out in 2019 or 2018. I can't verify that for sure, but just keep that in mind. I want to dimension this line, and I want to reference this endpoint. Notice when I do this, I get a little crosshairs on that point that I selected. It allows me to choose a cardinal direction, north, south, east, or west right here. I'm going to go ahead and choose east, and I can place this 20-degree value without selecting anything else. That to me is pretty cool. I don't actually need another piece of geometry. It knows to dimension it horizontally. So that's a cool trick. We'll use that again later on. All right, so I've got my 20-degree attack angle. It's not touching anything that it's supposed to right here. So this 20 degrees is supposed to basically be at this intersection point where it interfaces with the other gear. I'm going to show you. So what I need is that tangency point where that point is to be perpendicular to here. So we're going to go ahead and we're going to add a construction line from here to here. And we're going to say that this construction line and this attack angle need to be perpendicular to one another. This tooth profile needs to be tangent to that. And this all has to happen at this one point. So see how I'm using a whole bunch of sketch relationships to define this for me at this point? Well, here's the kicker. What's the angle between this construction line and this construction line right here? Well, geometry says it's 20 degrees. So you actually didn't have to do all that work. So if you're trying to follow along at home, I made you do a bunch of work you don't have to do. Always remember your acute and obtuse angles and your ability to go in there and define these in different ways. Always look at the problem in a variety of ways. Let the software do the math for you that you otherwise don't want to do. Now, the last thing I need to do, I'm going to turn this into a construction line because we're not going to reference it. I could do this all with contour profile selection like I showed you earlier, but we're going to be creating a loft here in a little bit later. The question, can I make the 20 degrees a variable in my equation manager as well so I can change it? Awesome question in the comments. Let's do that. Let's close this sketch really quick. Let's go in here, manage equations. Let's add pressure angle. I love it. Equals 20 degrees. Okay, so now we're going to go back into this sketch. How do you add an equation if you've already typed the dimension in? This is a great question. We're going to double click on this, and all we have to do is update it and say that's going to equal. We're going to go into our global variables. There's our pressure angle. Boom. That was a great question from the comments. I love it. So now we have 3 values over here, and we're going to look at changing these all later on. All right, so where I was here, I want to finish trimming this. We're going to trim this arc down here, and we're going to trim this arc and these entities here. The reason I'm trimming them is because I'm going to be creating a loft and a sweep a little bit later on. I'm going to start with a spur gear, and then we're going to show how to turn this into a helical gear. So lofts really like closed profiles at the end of the day. All right, so we've got our sketch. What's next? Let's simply cut it. Let's go up to our features, create a cut extrude. We're going to choose through all in both directions. I just want to cut all the way through this thing. Hit OK. And there we go. We've got our cutout. Everybody can probably guess where we're going next, what the next feature in the feature manager tree is going to be. Circular pattern, maybe. I can tell you what, it's actually not going to be a circular pattern. I'll do the circular pattern first, and I'll show you why you want it to be another feature in a moment here. So let's create the circular pattern. We're going to create a circular pattern. What are we going to create the pattern about? I've created no axis in my model. So here's a couple things to know about creating circular patterns. You can actually select circular edges. You can select circular faces, or my favorite thing in SOLIDWORKS is this thing called a temporary axis. This is an axis that is created for every single cylindrical feature or piece of geometry you create. I hotkey this actually. I go into my customizations and I toggle this. This is Alt-A, toggles all my temporary axes on and off. Shift-A is my actual axes that I create inside of here. But we're going to go ahead, we're going to create the circular pattern about this face. The features, oh, we need to add a fillet in the bottom of this tooth. I forgot about that. My bad. This fillet could be created in the sketch, and there's no reason not to do this. But we actually want to create the fillet here because one of the questions asked earlier on was, how can we use equations in features as well? So we're going to take a look at this. We're going to add a fillet to these bottom 2 edges. Now, the fillet on the bottom of this is 30% of the module value. So anywhere you see that you can enter a number over here in the property manager, again, you can type the equals key, and we want to do 0.3 times, just like before, the module value. When I press OK, when a feature is driven by an equation, you'll see that we get the equation symbol in the feature manager tree. So we're starting to see equations are available anywhere you want them to be. So we're going to go ahead and press OK. So now I'm going to ask you the trick question about what the next feature is. Is it a circular pattern? And again, I'm going to go back and say, you'll see in a minute why it actually may be something else. So here we go. Let's create that circular pattern. I'm going to access this from my shortcut menu. We're going to pattern it about here, and we're going to select the tooth cut and the fillet in the bottom and the number of teeth. I could type this in, but remember in the very beginning, some of the really important values we captured the number of teeth as a variable. So I'm going to press equals again. And this time I'm going to just start typing it because this is easier for me to go ahead and access these there. I'm going to go ahead and press OK. And that's going to set the number of teeth to 25. So there we go. We're starting. I'm going to hide my sketches. So all of these view things. Here's a quick tip. I set all of these to hotkeys. Shift S is my view sketches. I turn them on and off all the time. I said Alt-A. That's my temporary hotkeys. So look at setting your hotkeys for things that you need to do a lot. All right, the next thing I want to do to this gear is I want to put a chamfer on the teeth right here. So I'm going to go in here and I'm just going to grab an edge. I'm not going to pick the chamfer command. We're going to grab it from the hotkey. And I'm going to go through here and pick, oh my goodness, that's going to be 50 edges. So one of the things that they teach very early on when they start talking about learning SOLIDWORKS is the order you create your features has such a big impact on how your models are built and also the complexity of them. Notice what we can do here. We can say, before we create that circular pattern, I'm going to roll back in the tree, grabbing that rollback bar, and we're going to add our chamfer now. I told you it wasn't going to be the circular pattern that we were going to create next. We're going to break these. We're just going to use a simple 45-degree cut that is equal to the module value, which is half of the tooth height. So I'm going to go ahead and we're going to do a distance, and we're going to make this a symmetric chamfer. And again, this time we're going to reference the global variable module. Now, there's other ways you could do this. If you wanted to put a curve on there, you could draw a sketch on the right profile, and you could draw that arc, and you could give it module times 2 and module over. That's another way that I've seen that value go in there as well. So I'm just doing this to make this go a little bit quicker here. So go ahead, we're just gonna break those teeth that way. And notice when I roll back, this has no impact on my feature pattern or my chamfer my tooth pattern that I've created there, sorry. Okay, I got 20 minutes left and I got some other cool stuff I wanna show. So I'm gonna speed it up here a little bit. I'm gonna take a quick look at the questions. Wouldn't you use tip and root ratio first, then pattern? Yeah, so this is kind of where I'm talking about that. If you wanted to put depending on how you break your teeth, absolutely, you could go in there and do a sketch and do a revolve cut around there. Maybe another way that you want to do that there. So one of the other things I should be pointing out is in my right mouse click menu. I am right clicking and pressing OK all the time. I do this by habit. I saw people commenting on this, and I forget I do this all the time. You can exit a command in the property manager here. You can do it up here. You can right click right here and press OK. I use my mouse gestures. This is so, mouse gestures become such a natural thing. I saw this comment. I've mapped, you can actually map OK and cancel to swipe right, swipe down and right for cancel. And I just skipped that I had done that. I forgot that that's not out of the box setting. So good catch there in the comments. Which key is the shortcut to show temporary access? So that's not a default. You know what? Let's take a minute here. People are asking about hotkeys in chat. If you want to set a hotkey, you want to right click on any toolbar, go to customize. Here's where you can set those mouse gestures that we were talking about. So I've gone through and dragged commands onto here. So for example, OK and cancel, right? I wanted to put OK. There it is. I drag it up, I put it on there, and now it's in my mouse gestures. The hotkeys people are asking about are under the keyboard settings. And what you basically want to do, I set all my views, I type view. And you'll see here, I set zoom to fit is F. O for orientation. Where are the hot ones? Right here. I set axis to shift A, temporary axis to alt A, origins to shift O, P to shift P, points to alt P, and sketches to shift S. You can come in here and kind of tweak these and customize these. And then if you create a list and you forgot what they were, you can actually print this whole list out right to your printer, tape it onto the side of your monitor, and eventually they'll become muscle memory and you won't have to worry about that. So, all right, so we've got our gear here. At this point, we would start creating a bore, a keyway, and all this other stuff. I'm gonna save this really quick. What I wanna do is with our time, I wanna make sure we look at how do we create a helical gear. So we've kind of created the basis of a spur gear. I want to now look at how would I make this as a helical gear here. So we're going to roll back. This wouldn't be done with a cut. I want to go back to where this sketch was that I created, kind of back here, but it's between. I want to go back right before I created this cut. How do I do that? Well, this is a great question, and there's two ways to do this. You can right click on your feature manager tree and you can actually change between displaying your tree as nested items or what's called a flat tree view. And notice how the tree display has changed. It's now showing me each feature, including sketches that I've created one at a time. Now this can make your feature manager trees get long. So what if you don't want to do that and you still want to go back in time before this sketch? You can actually drag this bar in between this feature and this sketch and watch what happens here. It says this feature will be temporarily unabsorbed from the sketch. If I press OK, look what happens. It actually pulled the sketch out temporarily out of the feature so that I can now access this. Let's turn my sketches back on with Shift S, which is my key, or from the drop-down menu up here. What I'm going to do is I want to create this at an angle right here. So how am I going to capture this angle? Well, if I look at this from the top view, and I'm going to go normal to, so again, here I'm going to use mouse gestures. See how I have normal to set as a standard mouse gesture I use all the time. We're simply going to draw a line that's going to represent our helical gear angle. And I know what question I'm going to get. Somebody's going to ask me, could we create the helix angle? Absolutely. So let's go ahead and do that right now. Let's get that helix angle in there before that question gets asked. Okay, so we want to make sure that this is where the center of this tooth is right here. Remember in the very beginning I said I extruded this about a midplane? And I said I did that on purpose? It's because if the middle of my part is right there, I can set the middle of this line to be midpoint, and look what happens. No matter how I move this endpoint is always the same, is always symmetric about the center of my part. Well, it's symmetric on the opposite sides, if that makes sense. So now we're going to set that angle right there. And what I'm going to go ahead and do is we're going to add a dimension to this. So I'm going to go ahead and do that trick we showed you earlier. I could dimension to the right plane. I'm going to dimension to this line, grab the endpoint here, and again, I get my my coordinate system, and I'm going to say I want to go right up like this, and that's going to be my helix angle, which is also 20 degrees. We're going to show how we can change all these in just a minute. All right, so we have that value. We've got that line, but that line, how am I going to use this? Let's take a look. Could I do a swept cut using this? Let's see. Let's try. Let's create a swept cut with this profile, and we're going to use this line, and it goes in one direction. Well, a really cool feature we added within the last couple releases was bi-directional swept cut. And you may think this works, but the problem is if we change that angle, that 30 degrees, you'll really start to see that that doesn't work. So what we're going to do is we're going to change that helix angle. Notice what I'm going to do. I'm going to right click on one of these values. I'm going to say that I want to go in and edit it, and it's going to open up the equation manager. We're going to change that to be 30 degrees. And as soon as I press OK, it just updates for me. Notice, it might be hard to see on screen here, but notice this tooth is significantly smaller than it is there. And that's because our gear is curved. We need to capture that curve on our gear. So that's not going to work. How do I capture this angle on the curve of a surface? Well, this is where projected curve comes in. We're going to go up to our curves and we're going to create a projected curve. And we want to project a sketch onto a face. And I'll point something out here. You have to select a sketch with this. If I select this line and then I select this face, nothing happens. For some reason, I have to actually select this sketch, and then when I didn't have face selected anyway. You want to make sure you grab the actual sketch itself, and then it will project up onto that face. We'll hit OK, and now I have a curve that follows the contour there. Now, what are we going to do? I think we are going to create, let's try that swept cut again. That seemed like that was pretty easy. We're going to use this profile, we're going to use this path, and we're going to do a bi-directional swept cut. Boy, that looks pretty good. So the way a sweep is created is different than how a loft is created. And I want to give you an example here. So to do this, I have an assembly here that I've already kind of created to show this. So if you create a swept profile, what happens is it'll follow that curve, including any strange twists and things that it may do along there, and it's actually not going to give you the results you want. What we actually need to do is we need to create what's called a cut loft instead. We need to maintain that profile on the front of the face and the back of the face across that curve that we're going to create right there. So let's go ahead and take a look at how we can do this with a loft instead. Let's get back over to our gear. Oh man, I got 10 minutes. All right, so not a swept cut. So how are we going to create a loft? Do I have to draw this sketch 2 more times? I saw this in one of the earlier live designs, and this is an old, what we call an oldie but a goodie, derived sketches. They're really powerful and they're really useful in cases like this. I want to copy this sketch, number 2, onto this face. So I held my control key there, right? I selected the sketch and the face. And I can go up here and I can go to insert, and there it is, derive sketch. And what does it do? It creates a copy of that sketch on that face. But it's not just a copy. It's a copy that if I change anything in the first sketch, the second sketch always stays up to date. But the geometry is all blue, which tells us that it's undefined. Well, you can grab any piece of sketch geometry in here and use that to make that concentric to that arc. So now it rotates properly. The next thing I need to do is I need that point to fall right where that curve passes through that point. And I've seen this discussed on live design as well. This is a really good tip right here. There is a relationship whenever a line, imagine this, we're going to take a line and go right through a plane. That point where that happens, that's called the pierce point. So if you grab this line and this point right here, you'll get a unique relationship style called pierce. And notice that that now fully defines that sketch. I'm going to go ahead and close that. And now we're going to replicate the same thing on the back of our part. We're going to pre-select our initial sketch and the back sketch. And I'll tell you what, I can't stand using the little pull down menus in the top. I'm going to press my space bar, or my S key. I may have rechanged my hotkeys in SOLIDWORKS for that. The S key. Notice when I do that in the upper right hand corner of the user interface, I have this thing called command search. I can just start typing the name of the command and there it is. I press enter and it's done. It's that easy. So this is really cool if you know the names of commands. You can, whenever you press the S key, I could type fillet, for example. Notice that. I could create a fillet if I wasn't in a sketch. So same thing as before, we're going to really quickly add a concentric relationship here. And we're going to grab that same pierce relationship right here. So basically what we've done is we've replicated that sketch relatively quickly across the front face and the back face as well. All right. So now what we're going to do is we're going to create a lofted cut. And we're going to select our profiles, and I'm going to select the top right here and the top left here and the top right here. I think this has been some live designs, but just to reiterate, where you select on a sketch when you create a loft is actually really important. What I've done by selecting near the top left is I've told that top right point, which I've selected, to loft over to here, and then I went back. But don't worry if you ever make a mistake. These drag handles make it really easy to just simply put the loft back where you want. The other thing that I'm going to do, just for a little peace of mind here, is not guide curves, because guide curves are great for curves that touch geometry in your sketch. I'm going to use what's called the center line parameter, or the spine of this loft, and I'm going to choose that arc that we had created. So now we've created our proper helical cut right there. Okay, So what do we need to do? We need to fix everything downstream right here. I am going to go through and you're going to see a mess, form. I still have my cut in my design, and I did this on purpose because I want to change this fillet to not reference the edges in the bottom of that cut. I now want it to reference the edges in the bottom of my helix. My chamfer is fine, and my circular pattern we are going to edit, and we're going to remove this cut, and we are now going to select this this lofted cut, and now we can go back and delete this cut. Now, the reality is I could have deleted that feature, but it would have deleted this fillet, and it would have deleted this pattern, and I knew I was going to need those later. So, there we are. We now have our helical gear. Looks pretty good. Now, there's other stuff we could do here. I want to look at why did we spend all this time creating equations? Well, guess what? I gave you the wrong values at the very beginning. I did not want a 2 millimeter tooth or 2 millimeter module gear with 25 teeth. I wanted a 0.6 millimeter module gear with 56 teeth. Well, that sounds like a lot of stuff to go back and change. Well, here is where by creating this as an equation really pays off. I'm going to right click on this value and go to manage equations. What did I just say? I wanted it to be 1.6. Think back to our equation that we made down here, our if-then equation that we did. Because that is now going to be a finer value, it's not quite finer, but if it was finer, that would update, it would change that equation to be a different multiplication value. Our number of teeth, I said I wanted it to be 56. All right. Let's change that pressure angle. Let's go to a 10-degree pressure angle. No, I don't like 10 degree. We'll just change it to 15. Let's change this helical angle down to 20. We're going to change all these values. Now, here's where the magic happens. I'm going to press OK. Give it a second, rebuild all those features, and voila, I have now created another gear that has a different module value, a different number of teeth, a different pressure angle on it, and a different helical value on it. So there you have it. We've kind of gone through. I'm going to take a look at the comments. I don't know if I'm allowed to do this or not. If the moderator can ping me and tell me if I can go into bonus time, I will. If we need to keep this to an hour, I'll cut this off here. Anyway, let's take a quick look at the questions. Thanks. Yeah, absolutely. Many solutions. Pierce typically only has one solution. That's right. So a pierce, when you select a line and it goes through a plane, there will only ever be one solution for that, where a line will go through a plane. That can only ever happen at one place. On a flat plane, keep in mind on a spherical or a circular surface, pierce could technically happen on the far side or the near side right there. Let's see, what else do we have here? Something about wrong dimensions happens all the time. Oh, I think I typed in a wrong number back there. Absolutely. Who wants bonus time? We want bonus time. All right, so I can go. I was told I can go for it. Okay. So we've talked about creating this gear. I could go through and I could create all the other cuts and features. What I want to do right now, I want to show how do we make all these gears work. So we're going to go into, we're going to say we're at the hour. Now we're going to look at some assembly mate stuff. Probably another 10 minutes is probably what I'm looking at right here. So let's go ahead. Let's save this and let's close this. This isn't a very fun example. Let's go to this example, right? So how do we take all these gears and make something really cool that kind of moves around like this? We have on the back side, we have a worm gear driving a spur gear, which is driving a helical gear, which is driving this spool up to this thing, which drives this crazy looking cam up top. I actually had to put arrows on these models so I could keep in mind which direction they all had to go on here. So what we're going to do is we are going to delete these mates, or at a minimum, we're going to suppress these mates. and we're going to take a look at how do we mate gears inside of an assembly right here. So now nothing works together, right? So if I move this, nothing else moves with it. So I'm going to move that back to where it needed to be. What we're going to do this predominantly with what's called the gear mate inside of SOLIDWORKS. So I'm going to go ahead and we're going to access the mate tool. A lot of mates people create in SOLIDWORKS, they do by selecting a couple faces, and then you have these quick mates. The mechanical mates that you can create in SOLIDWORKS aren't available from that menu. So if you're using all the quick key shortcuts, try clicking on the mate tool and explore a little bit. So there's some really cool advanced mates. Profile center mate, symmetric width and path are all awesome. So are limit mates. I mean, these are way more fun than standard mates. But I want to get into the mechanical mates. We have cams, slots, hinges, gears, rack and pinions, screws, all sorts of really, really cool mates that we want to create in there. The first mate we're actually going to create is going to be on this worm gear, because this one I'm just going to use some numbers for, because worm gears are a little bit different in how they interact with one another. So this spur gear and this worm gear right here. The first thing you always want to do is I like to grab a piece of geometry and mate them parallel to one another so that their teeth are perfectly aligned before you create this mate. So I'm actually going to show what I mean by that. We're going to open the boring assembly back up. Let's hide these two and let's get rid of this mate right here. So before I create this mate between these two, you want to make sure that they're lined up properly, right? So how do I go about doing this? Well, one of the things you can do is, remember, I created a center line down the center of the gear and also a center line down the middle of the tooth. If I make these two coincident to one another, they're going to lock. Now, here's the problem. They're not only going to lock, they're going to fully define this assembly. I can't move these components anymore. So that's not really what we wanted. Here's a really cool trick with mates that you can do. You can come in here and create this mate between the tooth and the gear. And what you can do is you can say, I just want to make this for positioning only. So I click this checkbox down here in the lower left and I hit OK. It positions the components, but notice what it did. It didn't fully define them. It actually didn't add the mate to them. So let's look at the basics of a mate. Well, we're right here in this assembly, in what I call boring assembly. The easiest way to create a mate between two components or a gear mate between two components is to go to the mechanical mates, grab gear, and you grab a cylindrical surface on the part. I'm going to add a really not fun surface. I'm going to grab that cylindrical surface and this cylindrical surface. And notice what it does. It gives me a rough value here, either tooth or diameter. When you select a face, it by default grabs the diameter of that circular surface that I've grabbed. So I could come in here and I could say, well, these have 56 teeth apiece. Let's type 56. And we hit OK, and voila, these gears now work together. But that wasn't actually the best way to go about doing that, to be honest. Let's take a look at what would have been the smarter way to do this. Let's clear our selections. Remember, when we create a gear, we draw a pitch diameter circle. That's the circle where those two gears mesh with one another, right? And notice one of the options in the gear mate dialog, or the default, is the diameter. In this case, their pitch diameter is 30. I don't even have to change the values right here. I can just choose that pitch diameter circle and press OK. And look at that. Our gears now mesh together. What if these were pulleys? You can actually go in here on a gear and you can reverse this. Now that flipped around. And you could actually do these as pulleys. So even though it's not a gear, you can use the gear mate to create a pulley system as well. So let's go ahead. Let's go back to what we call fun assembly. And let's create a complicated gear mate between this worm gear and this spur gear right here. So we're going to go grab a mate. And we're going to go to mechanical mates, gear, and we're going to grab the driving worm gear. And worm gears are always kind of done at a ratio. The trick I just showed you really can't be done for a worm gear, so I want to show how to kind of do this I guess I'll call it the old-fashioned way. And then we're going to grab one of these cylindrical surfaces here, and the ratio of this is 1 to 24. So now when I hit OK and OK, now you can see that these two are driving one another right there. So there's the gear mate there. I'm going to set those back to their positions. Now we're going to come over here. We're going to mate these two gears. Well, I'm going to use my hotkey, which turns on View Sketches. And these were already lined up. So guess what we're going to do? We're going to mate, mechanical mates, gear mates, and we're going to grab our pitch diameter here and our pitch diameter here. We're going to press OK. So what is this looking like? Notice I'm just checking every time I go through here. Everything seems to be working. I'm going to go around. We've got one more. And now the question's going to come up, what if I foolishly, or what if I did not create that? I'm going to get into some craziness here. We're going to create our gear mates. And we're going to go right here, gear mate, and we're going to grab not pitch diameter circles. I'm going to try to grab circles that don't accurately represent the number of teeth on these parts. So 1 in 6, that is not a 1 to 6 gear ratio. That's actually 28 to 56. I'm going to go ahead and press OK right here. And they're not going to move correctly. You can see that the gear ratio is all wrong. So how are we going to drive this value? Well, every single mate that you create has a number in it. So what we're going to do is, let me grab the right gear right here, and we're going to go into our mates and we're going to double click on this gear mate that we've created, and you're going to see a couple numbers show up. This number 1 right here. I can actually drive this with an equation. So I'm going to double click on my teeth and I'm going to say that I want this value to be equal to, and I'm going to go grab the number of teeth from that part. So in an assembly, I can drive mates with equation values. Let's do that one more time. We're going to grab the mate value up here that we had on this part. So we're going to expand the mates. That one was 58. Where's my other value? Up here, 6. We're going to double click on it, double click on it. There we go. And we're going to double click on our gear. And we're going to say that that value is equal to the number of teeth in that part. And guess what? Oh, it doesn't look, oh, let's do a rebuild. There we go. Now they're driving. I did them opposite. It looks like I grabbed the opposite values right there. So always use the pitch diameter circle if you can. It looks like I got the two values switched around in that case. Last thing I want to show is one really cool mate right here, and it's called the path mate. How do I make this guy follow along? Actually, I'm going to do something really quick just to kind of get this set back. We're going to delete that gear mate. And we are going to re-add it really quick. Gear mate, and I'm going to do pitch diameter to pitch diameter. That's not the pitch diameter. Do I not have it? Yeah, I do. There it is. All right, so now we've got that set up properly. I want this guy to always follow along this path right here. So I created this crazy cut sweep on this. And there's another type of advanced mate you can create. This is the last thing we're going to show, and we're going to be wrapping up. Just letting you know, we're going to create what's called the path mate. We can tell a point, any point, this could be a vertex of a model edge, a sketch entity, whatever you want it to be, to follow along a sketch. And I'm going to follow along that path. And I'm going to hit OK. And now if I turn all these sketches off, you will now see that everything works together. And because that sketch wraps back around on itself, that's a 3D sketch, that's a very complicated sketch, it allows that follower to kind of come along with it. If you're ever curious where the idea for this model came from, go ahead and go to your local sporting goods store and check out a fishing reel. That's actually kind of the inside of like how this works, or the winch on the front of like an off-road vehicle or something like that. So, all right, so let's see. We're going to wrap up here. What is the name of the book I had in the beginning on gears? Very good question. This is my very old 25th edition Machinist Handbook. This is when you go to school. This should, for engineering, this should probably be the very first piece of text anybody buys, in my opinion. I actually got this in high school because I started taking machining classes when I was in high school. So this is things like 25, 28 years old. That gives you an idea of my age. I still reference it to this day. This is probably one of the most valuable piece of texts you can buy and have on your desk. And I treat it with the utmost respect. I still do to this day. One of the cool things about SOLIDWORKS is a lot of the information in this book is built into SOLIDWORKS. If you have SOLIDWORKS Professional or higher, you have Toolbox, which has all the hardware that's in here. You can actually use Toolbox to create gears relatively quickly if you want to as well. So I got a thanks, good tips. Well, I appreciate everybody for joining me today. Remember, don't forget, when this video finishes, it's going to be available to watch after the fact. If you're watching this at a later date, be sure, add in the comments down below what you'd like to see us present on live design in the future. We're always looking for ideas. And let us know, like, do you want more beginner-based, more intermediate, more advanced? I would say this was kind of intermediate, maybe leaning towards advanced. I don't know. So let us know like how you kind of want us to do that. We're always open to ideas. Make sure you subscribe to the YouTube channel itself. Hit the subscribe button. And if you hit the bell icon, every Friday at 1 o'clock, your bell's going to ring, letting you know somebody else is going to be on. Our next presenter, Juan Chapa, is going to design a pergola using weldments. So if you're curious about how weldments work, stay tuned to that. And we also have SOLIDWORKS Live coming up on the 15th. Again, we're going to be meeting with Charles Adler from Square Robotics. We're going to be talking about, they make these really cool robots that go down into pipes and kind of do maintenance work on gas lines and things like that. So, yeah, I thank everybody for joining us here today. And until next time, we'll see you later.